Okay, so we've been talking about normal distributions. And remember, a normal distribution looks like this when you graph it. You've got a horizontal axis, and then you've got a bell curve. And the peak of the normal distribution is in line with what of the data? And mean and median, yes. But for our purposes, we're going to go mean. When we go about halfway down the curve, and we hit these two notches, how much of the data is in here? 68%. When we go two notches, and by the way, instead of saying one notch and two notch, I would say one standard deviation. Two standard deviations would be how much of the data? 95. And three standards, 99.7. So we, yeah.
There's no 2.4. Like on
There's no 2.4. Hang on a second. Okay. So we were able to answer some questions given a normal distribution, like a certain, like if we were given, say, test scores or something, which normally follows a normal distribution. I should say usually follows a normal distribution. Okay. We could find like what percent of the scores were below a certain score or between a certain score, as long as they were in line with the notches that was 1, 2, and 3 standard deviations away. Okay, so just as a review, and this example refers to something that happened in 2016 in Major League Baseball. The Miami Marlins, a pitcher had died in a boating accident, and the first game back, they held a ceremony, and the first batter up was a guy named Dee Gordon, and the pitcher against him was Bartolo Colon, and lo and behold, he hit a home run on the first, or on the at his first at bat, and that was his first home run of the year. So a lot of people thought at the time that maybe Colon maybe just kind of hung it out over the plate for him, just so that he could get that home run. Yeah, there's another teacher in here. You guys all right? Yeah, it's dark. Okay. So let's look at Bartolo Colon's pitching. He pitched well into Major League Baseball, into like 46 years old, and he was still playing Major League Baseball, and he still had a pretty good fastball. And 46 years old that's pretty old for Major League Baseball. Okay. So all his pitches, he had a mean speed of 89.4 miles per hour, okay, and a standard deviation of 1.7. And his pitches were normally distributed. Usually they were around 89.4. Then there were some that were higher, then there were some that were lower. So it follows a normal distribution. So if these are the pieces of information, you guys should be able to answer these questions for me right now. 68% of his pitches were between what and what? How would you find that? Right, 89.4 minus 1 standard deviation, okay, gives us what, 87.7? So it gives us 87.7 miles per hour, and 89.4 plus gives us 91.1. How would I find 95% of his pitches were between? Subtract 2 standard deviations. So you can either take the original and subtract 3.4, or take this and subtract 1.7, and you get 86. You add another standard deviation to this, and you get 92.8. And then 3 standard deviations, you do the same thing again. So 1.7, this would give us what, 84.3. And then add 1.7 gives us 94.5. So we're able to find some information using that empirical rule. Okay? But we can't find all the information, because not everything is laid out like 1, 2, 3 standard deviations away. So as an example, and this is where we're going to use our graphing calculators, find the percent of his pitches that were at least 92. Well, we can't do that because we don't have 92 as one of our notches. So we can't use the 68, 95, 99.7 rule. So we're going to have to find our calculator. Okay? What you always have to do when you see a question like this is you must draw a diagram with your answer. So the first thing we're going to do is we're going to draw a diagram. Remember, horizontal axis, mean, and then 1, 2, 3 standard deviations above, 1, 2, 3 below. And it's going to look something like this. Make sure you label it. Okay. And then we have the, I'm just going to cheat a little bit and just put those pieces of information in. So remember, we had the mean of 89.4. We had 91.1 for 1 above, 92.8 for 2 above, 94.5 for 3 above, 87.7 for 1 below, 86 for 2 below, 84.3 for 3 below. So you need this, and you need to shade what you're trying to find. So we are asked, what percent of his pitches were at least 92? So 92, that's around here. David, what area am I trying to find? To the left or to the right? Think of the phrase at least. Left? Doesn't at least mean 92.8 or more? Wouldn't it be this side if it said at most 92.8? So if it's at least, we're talking to the right. So this is the area we have to try to find. This is our question mark. Okay. And because we can't use the 68, 95, 99.7 rule, we got to use our grafting calculator. Okay. And we're going to find this area. Calculus does this for us, but calculus is going to do it on the graphing calculator for us. We don't have to worry about doing the hard labor. Okay, so get used to this, finding this. First of all, you have to go second vars. That means we're going to a distribution. Vars. Upper right, near the upper right. VARS. Right? And you'll have a whole list of distributions that we're going to use. Okay? We're going to go to normal CDF, number 2. And I'm going to write this down as I do it. So I'm going to do normal CDF. You got to enter 4 pieces of information. The lower boundary of the area I'm trying to find, the upper boundary, the mean, and the standard deviation. What's the lower boundary of this area? 92. We don't know the upper, but we want to pick a number that will account for everything. So we want to pick a ridiculously high number. And make it an easy number to work with. So let's do 1,000. Okay. I mean, we could have done, like, if we did 98 as the upper, maybe we missed a couple of pitches. So that's why, to be safe, we want to pick a ridiculous thing. Remember the mu? So, yeah. Yes, I'll explain that after I finish this. Yes. Remember, this is the mean of the population, mu, and that's what you're given in the question, 89.4. And sigma, yeah, is the standard deviation, which is 1.7. So enter all those values, 92, enter 1,000, enter 89.4. What's that? The stuff is already there? I can't hear you. You need to speak quicker.
Why delete the numbers that are already there?
Yes. What?
Okay.
You get so frustrated with me. Oh, that's sweet. Thanks. Okay, and then once you hit enter on the last one, it'll give you all the numbers listed again. Hit enter one more time, and you're going to get a decimal. And you should get 0.063. Sure. Make sure. So your lower is not, go back to your list. Your lower is 92.
Well, yeah.
No, because it should be listing like that. Yeah. So what I do when I was hit enter, yes. So I think you're going to have to do right. So you're going to have to enter all four at the same time, separate by columns. 1,000 comma 89 comma 7. Well, you gotta write them out any when you show your work. So okay. Point, Kira. 0.063. Ladies, which is how much as a percent? Just go to the decimal twice, 6.3%. That means 6.3% of his pitches were at least 92 miles per hour. Oh, yeah. Remember, you always have to answer in context too, so add this to your final answer. This is just 1 second. This is a completed solution. If you don't have the diagram, it's not complete. Okay? So like for the AP exam, they're not going to give you full credit if you don't have this. Yeah, bro.
What I look up, like, if I'm trying to figure out how to do my calculator, like, I'm gonna do a question for this, like, dollars per percentage or amount, what would you?
Finding a percentage given a value. And then there's the other one that we're going to do, finding a value given the percentage. You should have something like that too, but we'll look at yours later. So that's how we can use So really, we can use a graphing calculator even for the 68, 95, 99.7 questions, if we want. This is one way we can ask. So what percent of his pitches were at least 92? What percent of his pitches were between 85 and 92? Then you do lower 85, higher 92, and then the same thing here. Okay. Another type of question you could be asked, and we use a slightly different function, is we want to find the value given the area. So the 5th percentile of his pitches, we want to find the value where 5% of his pitches are that value or slower. So let's draw it again. If you have to draw it. Here, 1, 2, 3, 1, 2, 3, speed, 89.4. Numbers again were 91.1, 92.8, 94.5, and then below the mean were 87.7, 86, 84.3. This time we're given the area, we don't know what the value is. So where would 5% be? 5% would probably be somewhere around here, right? Like the 5th percentile. So we're not, so I'm just going to go like this for now, and I'm going to fill in the value later once I find it. So I know that this is 5%. I'm trying to figure out what value wherever it is. So we're going in reverse. And to go in reverse, or the inverse, you would go second vars, and this time you would choose number 3, inverse norm. And this time you are asked to enter 3 pieces of information. So you would do inverse norm. You are asked to enter the area. It has to be as a decimal. Don't enter 5. As a decimal, it's 0.05. So remember, decimal. Standard or mean is the same as the previous question we did. So 89.4. Standard deviation is the same at 1.7. When you do that, you're going to get the value. So 0.05, enter, or you would use commas, McKenna. 89.4 as the mean, 1.7 as the standard deviation, enter twice, and you should get 86.6. Miles per hour is the 5th percentile. So 86.6, if we do our diagram, it's going to be just a little bit past this notch. So it's going to be 86.6. So see how I sort of completed the question after I found the value, completed the shading. On your own or with somebody or two, try the next 2 examples, including a diagram. And if you guys have difficulties with your graphing calculator, figure out which function am I using, normal CDF or inverse norm. If you're finding an area on the distribution, that's normal CDF. If you're finding a value, that's inverse norm. So when I look at these 2 questions, it says what percent of students score So I'm trying to find a certain area in the 500s on the normal distribution. That's normal CDF. If you look at this second question, it's asking you 75% of 3-year-olds are taller than what height? Well, I'm trying to find a value and I'm given the area as 75%. This is an inverse norm question. First thing, draw the diagram of a problem. Don't just go right to the calculator. So for any of these problems, any of them, they're all going to start like this. Horizontal axis with 7 notches and a bell curve, a normal distribution. Don't forget to label. So we're talking about SAT scores. You could put SAT score or just put score. The notch values or the tick values, we get those from the mean and the standard deviation. The mean always goes in the middle notch. Then I add standard deviations to get the value of the 3 notches above. So I get 618, 728, 838. Now, some of you recognize to say, well, it's out of 800. Why would it go to 838? Yeah, technically you're right. It shouldn't go, there shouldn't be any values past 800. Okay, but if we did that, it wouldn't quite follow the normal distribution and we wouldn't get quite an accurate answer. Then we have to subtract. So what do I get? 398, 288, and 178. Now we put in our area. We are looking for the 500s. Therefore, the lowest possible score in the 500s is what? 500. So I want to locate 500, approximated, it's going to be close to 508. So that's my lower bound. 500. For the upper boundary, you could do 599 or 600. The difference in the areas between those two would be so minor, it would be irrelevant. Okay. So I'm going to do 600, which is, that's about, I'm just going to say over there. You did 599, that's fine. So I'm finding the area between those two. When you sketch the diagram, just 1 second, when you sketch the diagram, you will have the 4 pieces of information you need to enter into your calculator. Rush.
Can we do the percentages again? Will this be percentage?
Yes. Okay. So we've established that we're doing normal CDF. So normal CDF. And then once you enter that on your calculator, you should get a list of 4 values to enter. Some of you don't have that because you have a different calculator. You're going to have to enter the 4 values separated by a comma. The TI-84 will ask for the lower, which is 500. It will then ask you to enter the upper boundary, which is 600 or 599, whatever one you chose. It will ask you to enter the mean, which is 508. And it will ask you to enter the standard deviation, which is 110. If you've got the TI-84, you have to hit enter twice after that to get your answer. If you're entering separated by commas, you only have to hit enter once. But when you do this, you should get approximately, and I'm going to go to 4 decimal places here because I'm going to change the percent, 0.3275. If you used 599, maybe you got a slightly different answer. Go with the answer that you got. change that to decimal, 32.75%. And then add some text, as in context, scored in the 500s. How are we now? Better? Yeah. If what? 32.8 is fine. Yes. Sorry? No. Okay, let's look at the second one. Last example. So right away, how do you know it's one of these type of questions? First of all, look for the word normal or normally. When I see that word, that tells me I need this. So right away, I can start that before I even read the question. So we've got the heights, 3-year-old females. They're approximately normally distributed with a mean of 94.5, which is my middle number, middle notch, and a standard deviation of 4. So I can get my other 6 notches. On the right side, it would be 98.5, 102.5, angle. Two 2.5 and 106.5 and 90.5, 86.5, 82.5. What am I missing? Label. Yeah. I need to label my horizontal axis, and we could just put height. Height is fine. Now I want to find 75% of 3-year-olds are taller than what height? So that means I want to find the value that 75% of the area to the right. So 75%, it's going to be somewhere maybe around here. So I'm trying to find, I'm not going to enter my boundary value just yet because I don't know what it is. But I know that this is 75%, and I'm trying to figure out where that height is. Inverse norm. The area is 0.75. The mean and standard deviation are 94.5 and 4. Those of you that have the fancy one, and where it asks you like area left, center, right, well, this is to the right, isn't it? So make sure you highlight right. So when you enter those values, you're going to get 91.8. So 91.8 is, well, somewhere around here. Yeah.
And you're giving the label as guess, but then.
Yes, you're estimating for the diagram. Yes. Okay. So make sure you answer in context. 91.8 centimeters. Actually, I'll probably rephrase it. 75% of 3-year-olds are taller than 91.8 centimeters. And that's my final answer. Yeah. Okay, I'll come there in a second. Any general questions? Okay, so you can see what we've done in this unit. We've talked about location of data in a distribution using percentiles or Z-scores. We've talked about how to transform distributions by adding, subtracting, multiplying, or dividing by some number. And we've talked about a special type of distribution which occurs very commonly in everyday life, the normal distribution, and how we do calculations with that. So that's everything that Unit 2 covers. Okay, so I made a mistake here. Because what you have to do when you're using inverse norm, the area always has to be to the left that you enter. So we're finding 75% of the area, like we're finding this, we have to enter this because it reads the left side area. So it'd be 0.25. Sorry about that. So it'd be 0.25. I don't know if that impacts the newer calculators. I think you guys hit left, didn't you? Yeah, so that you don't have to worry about that. What's that? If and you have to put in left, center, or right. As long as you put left in, 0.75. Or sorry, right for 0.75. Okay. Yes, if you put in, because yeah, if you've got the ones where you're going to enter what direction the shaded area is in, go right, because if you're entering 75, it's to the right. If you're on a standard TI-84, you have to enter to the left automatically. So that's why you guys still got the correct answer, even though you entered 75. Okay, hang on. Whoa. Are we okay?
Yeah. Wait, so I'm trying to find the left.
Okay, you know what? I'll come there.